Hello, my name is Christine, and I'm coming to you live from the US, where I am the chair of the National Astronomy Education Coordination Team. I want to acknowledge that I am broadcasting to you from the Piscataway territory outside of Washington, D.C., the ancestral homelands of Native people. I also want to let you know that I am going to be sharing a bunch of resources for you. Here is the QR code that will also be presented to you at the end. I'm going to be talking to you today about the ways in which astronomy education and Earth and space can be used to inspire hope and change the narrative for students using astronomy. So the questions I have and what I look at is how we can connect Earth and space to equity, considering how students connect learning to their local environment, using space technology to attend to human and ecological perspectives on local and global scales, and how students can use space technology to connect their learning to their local surroundings. But we have some barriers to this inclusion. In the United States and abroad, women represent the lowest number of representative people in the sciences, in astronomy, and people of color are under 5%. Women are about 11%. So astronomers have generally been only white men. And a lot of that comes back to the fact that astronomy and earth science is not offered until college. In the US, we really excluded that from education, and I've seen that elsewhere as well. That means that the moment of career selection and being able to identify with those career fields has likely passed. And we're trying to bring people in once they're already adults without exposing them at earlier ages. Earth and Space also has the lowest number of course offerings and qualified teachers within the US. And in my research, I'm finding that abroad as well. There's no national certification to be able to even teach astronomy prior to university. In what we've seen in our research in the US in terms of education and science is there is this pedagogy of poverty, where in areas of high need, you have high teacher turnover, which influences a deficit thinking on the behalf of students. And all of these things just compound to really eliminate things that are seen as abstract or conceptual or unrelated to student learning. So there's limits to exposure of real world science or things of interest to students, and just the reduction of content to bare minimum standards, meeting ideas of what's on a test and really teaching to a test. And this removes local connection and just comes down to transmitting knowledge and compliance. And now, especially after 2 years of learning moderated by a screen from COVID and remote learning, students need hope. And astronomy has the opportunity to really pick students up, meet them where they are, and allow for innovative learning experiences. Earth and Space has the power to really inspire action, to empower our future leaders and decision makers who are going to be inheriting the world that we give them, including all of the problems that we give them to. They're going to be informing local decisions. And this science also has the capacity to disrupt colonial barriers and narratives. And it also can integrate all other content. So I like to think about this as not just astronomy, but a system, an Earth system science, and how we look at the world around us, not just the space surrounding us. So one of the ways that we can utilize astronomy to be able to teach students and inspire hope is by showing them that it's not just about looking at space, it's about looking at us. So here we can see some patterns from decades of animal movement. This leads into conversations about what do the colors mean? Where does this data come from? How would this actually be collected, and what are the implications? We could also see from the year in the life of CO2, and we can talk about data modeling and climate modeling, how these visualizations are created. If we look at the time scale in the bottom, we can see as this ranges from winter time to spring and summer, how concentrations change. Students often are confused as to what means high concentration, what means low concentration, and having to read the scale at the bottom. We can see gyroscopic flow in the atmospheric cycling of matter. And this leads into so many conversations. And spoiler alert, if you want to actually find this, this leads into really, really cool biologic discussions about where the concentrations are highest and why. I highly encourage you to check that out. I'll give you a hint. It has to do with photosynthesis. Some other ways that we can bring in astronomy to really change the narrative is things that maybe we wouldn't think of: history, governance, and economy. Take, for example, the history of spaceflight. We could talk about individual nations' motivations for having a space program, the influence of war, who was involved and who was actually excluded, who were the decision makers, what did they look like, who was not involved, who did that impact? How did this then influence international relationships, maritime laws, international laws? There's so much that we can look at just when we look at how the development of rockets and space programs, space systems. Of course, we can talk about art. There are international art contests and so many ways that we can talk about astrophotography and being able to bring in the visual arts to our classes when we talk about space. And I don't even need to remind you all about the integrations of math. The bottom line is it doesn't have to be a silo. We don't have to think about teaching space content as just an advanced class. It also doesn't have to be topic specific. It doesn't have to be only university or a selected elective. It doesn't have to be math centric. It doesn't have to be career driven or workforce driven. We can teach about space with the lens of other concepts. And building upon the work of Salimpour, he talked about astronomy as a gateway and gave this framework of the frequency and occurrence of where we see space content as a justification for using this as a lever, and being able to embed this within other courses or topics, so that astronomy supports and provides the lens for that content, not the other way around. We can see the opportunity to incorporate various worldviews that are connected to astronomy, and shifting from this idea of a singular endeavor to the collaborative and the global, which is how astronomy and science is actually done. We can use this to generate interest, interaction, motivation for STEM. We can shift the perspective and the focus during middle and early years. And this gives us the opportunity to address the real issues in science and the real implications and consequences of failing to address that. And it gives us the opportunity to allow students to collaborate and opportunities to provide the education sector with collaborative insights within the scientific community, and also to investigate common topics at every grade level. For example, even in kindergarten, having students look at common phenomena, everyday phenomena surrounding their schoolyard, and looking at that through multiple lenses with a space perspective. So some examples that I give you in some of the things that I'm sharing with you are ways to explore Earth and space through Google Earth, through a program called Stellarium. I really like the web version, and something called ArcGIS, which provides GIS maps for racial equity. And I also am a big fan of star-gazing apps. So Google Earth allows us to make projects, to do time lapse. And in the materials I'm providing you, I made a whole tour using lost civilizations. And this allows students to explore the world around them using space technology. They can even investigate things like natural disasters before and afterwards. They can measure the way coastlines change. Stellarium is this really amazing program that allows students to investigate celestial motion. They can select distant times in the distant past. They can actually look at ancient astronomy. They can look at context of cultural astronomy and how their ancestors may have seen the sky. They can find a place they want to go. They can look at what the stars would look like there. They can investigate seasons by going to different places on the planet and then comparing that with Google Earth. They can compare the equator and the poles in different latitudes. And they can also leverage things like robotic telescopes and capture imagery. One thing that I like to do when I provide this lesson for you is reading the sky, where students can choose a civilization, find the location of that civilization in Google Earth, set the stellarium to that location, observe the motion of the night sky, think about the stories that were told to explain this phenomena. How did those stories relate to everyday practices and depict the creation and life cycles of people, of animals, of the world? And what other people and place groups have stories about these constellations? Thank you so much. Here's my contact information. Please feel free to reach out. And here is the QR code for all of those resources that I shared. And if you would like those or any sort of collaborations, please reach out. Thank you.